Hello, this is Mrs. Ringrose, and we are moving right along, solving multi-step equations. We talked about how you have to combine like terms before you can do inverse operations, and also before you can perform inverse operations. You have to really pay attention to make sure that the equation is simplified first. Sometimes you need to use the distributive property first. So in looking at this first example that I'm giving you, again simplifying first, solving second, you notice that you have this 3 that you want to distribute. So you're going to write for me 3 times 2x plus 3 times 5, and then everything else comes down. That 7 is not inside the parentheses, so he's not going to get the 3 multiplied on him. So what we did there was distribute. Next, you're going to show me that you know how to actually multiply. 3 times 2 is 6x plus 15 minus 7 equals 50. So you multiply it, or you can write simplify. Nothing to lose. The next thing you want to do is combine your like terms. 6x is the only x term, but I can do 15 minus 7, right? So I get 6x plus 8 equals 50. And from here on, it's just like all the other stuff you've been practicing. So you probably don't even need me after this, which is great because I want you guys to feel like independent learners. You're noticing that it is 6x plus 8, so I'm going to use the additive inverse property to get rid of that plus 8 by subtracting 8 from both sides. Again, whatever you do to one side of the equation, you have to do to the other side. So now a positive 8 minus 8, that goes away, and I have 6x equals 42. And I'm not done yet because I have 6x is equal 42. I need to find out what 1x looks like. So I'm going to divide both sides by 6. And I have finished this equation because I just have x left. And of course, I always want you to go back and check to make sure it's a solution because I want you guys to all get hundreds. So, does 3 times 2 times 7 plus 5 minus 7, this should be in big parentheses, like that, sorry. Does 3 times 2 times 7 plus 5 minus 7 equal 50? Well, if I do inside the parentheses first, because I'm following order of operations, I have 14 plus 5 minus 9. All right, so then I have 3 times 19 minus 7. 3 times 19 is 27. I'm sorry, not 27. I lied. 3 times 9 is 27. It's 57. Thanks for paying attention. So yes, these are equal, and I got it right. All right, so again, if you need to watch part of that again, you can, or ask good questions. We have a couple other examples. Some are a little bit easier than others. All right, so you're actually going to want to check this out. If I don't have something, so there's 2 ways you could do this one. I could always do this, and I get 36 still showing our steps a little bit. And I do the multiplication, so I get 36 minus 28x equals 316. And then I'm going to want to use the additive inverse, so 36 minus 36, because I got to do this on both sides, minus 28x equals 316. These go away, and I'm left with negative 28x equals 280. And if I divide both sides, by negative 28. I get x equals negative 4. I'm sorry, not negative 4, negative 10. And then I could check my work. There's also another way to do this. You don't have to erase your work. Maybe if you want to rewrite it down at the bottom. This is a fine way to do this, by the way. You can totally get the right answer with that. But when there's nothing outside of the parentheses like this, you can actually go ahead and divide everything by 4 because we're reversing the order of operations. So you'd have 9 minus 7x equals, and I'm not sure, 79? That sounds about right. Kind of need to use a calculator for that. Right. This is just kind of like that fraction one where everything was being divided. Now I'm going to divide both sides by 9. I'm sorry, subtract both sides by 9. So 9 minus 9 both sides. These guys cancel out because 9 minus 9 is 0. I bring down a negative 7x equals 70. And then I divide both sides by negative 7. And I get x equals negative 10. So imagine that. I got the same answer. So that's what one of the things I love about math is I can do this different ways and I can get the same result. As long as I follow my order of operations, that is. All right, and I'm going to start you on this final example because there is somebody outside of the parentheses. I have to distribute first. I have to simplify. So 2 times negative 5x minus 2 times 3 plus 4x equals 6. Now you're going to show me that you know how to multiply. And I get negative 10x minus 6 plus 4x equals 6. All right, now I have to do a little bit of regrouping here because I want to put my x's together. Some of you are feeling confident and you want to skip over that step. I would recommend whenever you have negatives to never skip over that step. But you know your skills best. So negative 10 plus 4x, because my 4 is positive, plus 6 equals 6. I'm sorry, not plus 6. That 6 is negative. All right. Now I'm going to want to combine like terms. Negative 10 plus 4 is negative 6x minus 6 equals 6. And I'm noticing I'm going to have to add 6 to both sides to get rid of this one using the additive inverse property. So negative 6x minus 6 plus 6 to both sides equals that 6 plus 6. There's a lot of 6's there. My goodness. I think I'm all mathed out today. Negative 6x equals 12. And my final step is I want to get the x alone by getting rid of that negative 6. So I divide both sides by negative 6. And I get x equals negative 2. Are we going to check this? Of course we are. We always want to check our work to make sure we get it right. I'm going to put that negative 2 back up into the original equation. And you can just throw this in the calculator at this point too. Does 2 times negative 5 times negative 2 minus 3 plus 4 times negative 2, what does all that equal? Well, we're hoping it equals 6. Inside the parentheses, negative 5 times negative 2 gives me positive 10 minus 3 plus 8, negative 8. 2 times 7 plus negative 8. 2 times 7 is 14. 14 plus negative 8 is 6. Yay, that's what I want it to be. So this is checked. And oh my gosh, this video is also 10 minutes long. I'm so sorry. But again, if you had stopped watching me earlier because you're good to go, that is fine. I hope this is helpful, though, if you need to ever come back and check to make sure you know what you're doing. And as always, ask me good questions. Thank you.